Welcome to another exciting episode of the NIDS View, a weekly show of the National Institute for Deterrence Studies, where we are advancing peace, promoting stability, and helping you to think deterrence. Each week, we will discuss and analyze a recent topic and provide insight to how it affects our national deterrence. The view of the hosts and guests are their own. We hope you enjoy the show.
Well, hello, audience, and welcome back to another exciting The NIDS View. Sponsored by the National Institute for Deterrence Studies, that's us. And today, you probably were thinking to hear Adam Lowther, but he's out on assignment. So you're lucky enough to hear from two experts in the area we're going to talk about, the new SAOC. And you have Curtis McGiffin and I to discuss what's going on with the SAOC and why it's important to you. And so I looked around for articles to talk about this week, and I thought this is a great article. One, because the SAOC is being flown right here in Dayton, Ohio, the beautiful garden spot of the United States of America. And
is that what they call that?
That's what everyone I know calls it. And it's just down the street from us, and I can't wait to hear that thing flying over top of my head while I'm out riding my horses here in Ohio. So if you're interested in the SAOC, stay tuned today because we're going to talk about it from operational standpoint and a technical standpoint. So for those that don't know, an article came out just recently. It was hosted, oh my goodness, I first lost track of it. Yeah, in air warfare, and we actually had some articles in our newspaper, the local newspaper, about this new aircraft. It's being built, or it's actually being put together by the Sierra Nevada Corporation, and they're going to turn out several of the Boeing 747s. And so they end up starting flight tests here in my area, and I'm going to get to see them. And I'm going to put up front here, by the way, Curtis, and you can tell your part about this, but the title of the article is Flight Tests Begin on the U.S. Air Force's New Doomsday Plane. And I really don't like the Doomsday Plane because I think that it gives it a connotation that, quite frankly, I don't care for. I think it's an aircraft with it's going to be an aircraft with incredible capabilities and incredible ability to deter our adversaries and make them fearful that no matter what they do, we're going to be able to respond in a way that they don't want. And therefore, they get deterrence. So without any further ado, because I'm not an airport or Air Force person.
Obviously.
I know how to fly in one and I know how to jump out of one. And don't give me any of that news about a perfectly good aircraft, because probably aside from this one, I've never seen one. So I'll let Curtis talk about his flight time there, and he can talk to me about some of the technical aspects of this new aircraft. So turning it over to you, Curtis, because you've been there before.
Well, Jim, thanks. It's this is an exciting time, and as someone who flew the NAOC for a few years, and I'm wearing my hat for those of you who are listening, and then I also wanted to show that I'm geeky enough to have my little die-cast airplane to fly by as we. That's how much I love my E4 NAOC. This is interesting. You mentioned that you can't wait to see and hear these airplanes flying overhead. The secret about it is, I guess it's not really a secret, but the sort of the untold portion of all this is that you probably have, because all of these planes are been purchased from Korea. They're former Korean airliners, which is an interesting way. So we're using refurbished aircraft, even though they are 747-8s, which are the most modern Boeing 747. They're not brand new. So refurbishing these aircraft is going to be, it's a great way to cut costs and provide a platform quickly, which is something that I think is it's always a bit of a challenge in our bureaucratic process to make sure we can get things quickly, especially when we need new things. To your point, so let's talk about the E4 mission writ large. I came to the E4B in 2000, the year 2000, and I was, I guess, a very junior major and was flying on that I flew in that mission for 3 years, including on 9/11. As my claim, my claim to fame is I guess I'm part of the 9/11 conspiracy, depending upon which video you've seen.
I know a few of those.
And I think there's a book out with that title and the E4 on the cover. I can assure you that was not the case. But it was our big war, and of course the airplane really did perform flawlessly on the day that our nation needed it. But the NAOC is for a long time prior to the B-2 bomber was the most expensive airplane in an Air Force inventory.
Wow.
Based on its costs, its modernization, its size, its cost to operate, and these sorts of things. And it's really quite interesting. It's got a crew of like 65 people because it carries all of its, in addition to all of its flight crew, and then sort of the battle staff that sort of do it, all the communicators and all the folks that are on this jet. It carries its own maintenance troops and its own security forces. So when the airplane can land anywhere in the world, it's got its own cops to protect it on the ramp.
There's a lot more to it than just flying around.
Yeah, absolutely. And that's because it's a high priority aircraft. It is a 740. Currently, the current versions are 747-200s, which are the same airframe as the Air Force One for the president. And there aren't many of those airplanes left. The 747-200, of course, is a very old version of the 747, and it's just getting really hard to get spare parts for these things. And of course, all the lines are closed now in building new ones, and so pushing up to the 8 model, the Dash 8 model is really going to enable a lot of different things, which we'll go over here, a lot of different benefits. But again, the SAOC mission, which stands for Survivable Airborne Operations Center, as opposed to NAOC, which was National Airborne Operations Center.
Not survivable?
Yeah, and that was, it was survivable. Someone got promoted, Jim, because they came up with that name and acronym, I'm sure, and kudos to them. So I would say that the goal of this airplane is really to ensure that the national mission is conducted on the worst of days, which is why it kind of gets this doomsday nomenclature, right? It's the Air Force calls it a highly survivable command and control and communications center that is used to direct U.S. forces, execute emergency war orders, and coordinate actions by civil authorities. Again, on the worst of days. So the airplane has to be robustly capable, not only in its mission to stay aloft, mobility is life, but to communicate through all of the most austere mechanisms. Right? If you're operating this airplane in the worst of days, which maybe like in say a nuclear war, you've got to presume that certain communication paths are going to be eliminated, certain command and control features that are needed to execute the war effort are going to be destroyed or somehow disrupted. And so this airplane really specializes in being able to move around the country or the world for that matter and ensure that you can connect in different ways with different forces in order to ensure that the presidential orders are carried out. And this, I think, is key to why this airplane exists. And lastly, Jim, I'll tell you, and to our listeners, it is extremely important to the theory and concept of deterrence, as we understand it with nuclear forces, that in order for deterrence to work, the adversary must believe that there's nothing they can do, right, to prevent the ability of our forces to be generated, energized, and, if you will, launched. And the NAOC and soon to be the SAOC will be are crucial to this happening as a mobile command center that can survive through the worst of times. And so with that being said, I would be very interested as an engineer, Jim, if you can explain what the worst of times can be, because there's a point in this same article that you're referring to where it refers that the Sierra Nevada Corporation is hardening these planes to protect against radiation, electromagnetic pulses, as well as adding communication antennas, computers, and mission systems that are often modular. And so this is a lot of the retro work that's being done to these old Korean airline. I want to say old Korean airline, former Korean airliners. Yeah. And so I'm curious, what do you think they're doing and why?
Well, that's a good question. Before I get there, Curtis, though, I don't remember. Did you tell everyone what your specific job was when you were on the NAOC? And can you say that you understood that it was part of a deterrence mission that you were doing? Or is that something that you sort of learned afterwards, back then?
Yeah, so I was a navigator on the jet, and so I was part of the flight crew. And yes, I understood the role. However, in that era, that pre 9/11, post 9/11 era, nuclear attack was something that was not necessarily a large worry for the country at that time, unlike today, where I think it is a much larger worry. And of course, the NAOC was activated on 9/11 due to a terrorist attack, but because nobody really knew what was going on that day, it was an extremely important system there with regard to how it was being position and why it was doing what it was doing. And we can talk a little bit more about that a little later in the podcast. But I would say that yes, it was. We had a very good understanding of what our role was in supporting that mission. The President, the Secretary of Defense specifically, or Secretary of War now, in some of these areas in how they travel and who's communicating with whom.
Yeah, it's great because, most Americans don't understand that we do that mission 24/7, 365 days a year. And those airmen are out there doing that mission for you, that deterrence mission. And so, glad that you knew that at the time. And hopefully the rest of the country now, understands that value of that mission. So, so let me hit on two things that I thought were exciting. I'm really excited about this podcast, this subject. So the two things you hit on, the primary missions, of course, is survivability, because if it doesn't survive, it can't do its mission. And then communications primarily. And building this system from the bottom up, from the ground up, is really important, because the original system, was built in 1970. I think the first one off the ground in 1979. And just to give an idea to our audience, 1979, Jim Petrosky was a junior in high school. Okay. And then I was going to be a senior and then go to college for computer science and engineering physics. And one of my first responsibilities was look at a chip made by, I think it was Intel, an 8080 chip coming out in 1980. So in 1980, when I started college, I worked with that chip, and it ran at a processor speed of 600 kilobits per second. Okay. Wow. 600,000 at the time. And I did a project, and this was so interesting because this is the year that it came out, and that was the chip. That was the military chip that was on that system at the time. See, I'm getting all excited, getting goosebumps.
You are.
Remember, I was a kid at the time.
Man, I thought your job was to repair the punch card machines.
Yeah. Well, we did use punch cards in our computer system. That's a whole other thing, and I can explain it. If someone wants to write me from the audience, I'll tell you what happens when your punch cards fly off your motorcycle. Right. It's a bad. It was the worst day of my life, at least that day.
Oh my gosh.
Okay, so anyway, back to this. So one of our jobs was to take the clock, the quartz clock that was driving that computer system, and interleave it so it ran at twice the speed. So it ran at 1.2 megahertz. And we were trying to see if it could still run programs at that speed. That's how slow it was. Okay, the original system. And today we're in the tens of gigahertz systems in the new system. And you say, well, okay, so they upgrade that. But remember, you're taking a system that was designed around that chip And now you're and trying to upgrade and upgrade and upgrade. But now we're starting on a brand new platform designed to do that. You're saying, okay, I'll get to the details, the engineering, Curtis, but this is really important for the audience to think when you start with a new platform rather than just upgrade. So I'm going to give you the simple answer because remember, I don't know if I told everyone this, but I live in the garden spot of the United States of America, Dayton, Ohio. And
you did mention that.
Oh, thank you. Yeah, I'm glad I did. So because here a couple years ago, we had several tornado problems, several tornado outbreaks. This year, not so many. I don't know. They told me there'd be more every year with climate change, but there weren't any this year. But anyway, thank goodness. I'm happy for that. But at that time, I was thinking I need to upgrade my house to survive a tornado. So first thing you want to do with your house is you want to get it partly underground. My house is not. It's built on a slab. So if I wanted to upgrade my house to be the best to survive a tornado, the first thing I'd have to do is have a construction crew come in and dig a hole underneath my house and then put it down lower into the ground. Okay, that way it would be more tornado proof. It'd be more survivable. Okay, imagine the construction costs and the problems to do that with the existing structure. Then we'd have to rip off my roof, which, by the way, I bought a new roof a couple of years ago. It cost me 10 grand. Yank that thing off and put on a new roof that would survive a tornado. And the problem with that roof is you don't want to overhang on the sides of the house. So you want it to come down along the walls. So I would put a new roof on that would not have these overhangs that wind could catch and pull the roof off, even if a tornado came by. But the problem with that, then I have to redo my windows because my windows aren't designed to have rain pelting them on the side. So now I have to replace my windows. Oh, and my siding too, and my doors because I want to make it survivable for the tornado. So basically, I'm building a whole new house. So what does this have to do with this new system? Well, they're starting from scratch. And Sierra Nevada is doing a smart thing. They're building it modular, and they're starting from the beginning. So what are they doing for EMP survivability? Well, going back to 1979 again. In 1979, we did not have a standard, an EMP standard for aircraft. It was emerging, but it wasn't there. So it was sort of ad hoc. And what we do is we put the whole airplane together and we built this great system called Atlas. It's the trestle out in Sandia National Labs or Kirtland Air Force Base, depending on who you are. At Kirtland Air Force Base, I guess it's on. But it's on at Kirtland Air Force Base. And we would take an airplane, pull it out, and park it out there and shoot it with EMP and see if it worked. Sort of at the end point. Nowadays, 2025, we can simulate a substantial amount of that and build from the first piece part and make it EMP solid, and then build the component EMP solid, then build the communications box, make it EMP solid, then surround it with a Faraday cage so if the EMP happens, we can model that out very well, build that out, and then use the aircraft frame as part of the shielding and understand how that works and build out from there. We can do it in a modular fashion, and we can also build it from the ground up. We don't have to start by digging a hole underneath the house and digging underneath like the old we would have to do to upgrade it. So we have new standards and we have digital modular engineering that we can do in order to field these systems quickly. So that's the first piece. The second piece is, we just simply didn't, we did use tests with, Marx generators and stuff to simulate the pulses and to do that. But we have so many other systems in which we can test component by component and build it into the system, sort of baking it into the cake rather than building a cake and then poking the chocolate chips into it. So that's the first thing. Okay. The second thing is, as I said, we can build the shielding into the aircraft and affect the other things. Because remember, I talk about my house. Okay. If the doors are underground, I have to do other things. I have to build ways to get out of the doors and get up to the side. The same thing happens with an airplane. You build all these things into it, then you have to change other components to make it better. And one thing this airplane has to do is it has to fly. So now you might change the aerodynamics. I don't know if you ran into that, or the weight rating, or the electrical power grid, power system inside the aircraft in order to support new electronics. All that's built into the system. It's baked into the cake. The perfect system. And if it's modular, if we come out with something new next year, we design it modular so you can pull it out, plug in something new. And I imagine as part of the modular design, they have the EMP testing built into it. I don't know if you remember, but and I don't know what happened with this aircraft, but I believe that much of the aircraft had to be altered after it was built to do subsequent EMP testing, by current injection or putting components on there to make sure that if it's in one of these Marks generators or EMP test facilities, that it could be tested inside. You have to alter the aircraft. I'm sure that they have test points on here, quick testing. Think about your car. You have this little test box, you plug it in and it tells you, oh no, your valves are going bad. Your fuel tank is not working or your fuel pump's not working. All that stuff is built in. We didn't have that in 1979. I'm guessing pretty well that they're going to build that into a system so they can very quickly fix and repair systems. As an engineer, I think about all those pieces because that's the cost of fixing and repairing things or upgrading them as they go. So from an EMP standpoint, it's great.
I hope you're right there. So what you're saying is that the fuselage itself, right, the aircraft itself is sort of the first layer of defense against these things by the way it's designed. And then the second layer is the shielding that's within the component itself, wherever it's sitting inside the airplane. And so you're kind of getting a twofer when you do those things. And so I think that's fantastic. And one of the challenges here is you've got to have the will to spend that money to do those things, because what you're describing, of course, makes everything a little bit more expensive. And our challenge here, Jim, is always that we've got folks out there who aren't really believers that this is a threat that has to be paid for. And so they're willing to accept what we call risk in the Pentagon vernacular. And so they try to save dollars by accepting risk by maybe only using one version of the shielding. Maybe we'll just shield the airframe and not the components, or the other way around. And then we find that when the proverbial excrement hits the fan, nothing works, right? Because it in fact isn't properly shielded. And so it's very important in these crucial aircraft, of which you only have a handful, that they all work. And so I think that's fantastic. Is there?
Well, there's another piece though, and I want to go back to my analogy of my house, because you talked about cost. First of all, I want to say hats off. People talk about the nuclear stuff. It's always cost overrun. It's always. Right. I looked up everywhere I could find. Now, maybe I'm wrong. Someone in the logistics community or in Congress can call me and tell me I'm wrong. But everything I saw on the net is they are on schedule and on cost. Everything is meeting their cost basis. So this is not an overrun. This is not a problem. But let me go back to another piece of this. I said if I wanted to upgrade my house and keep the current structure, I have to dig out from underneath it. I have to redo the roof, redo the walls, do everything. It would cost more to do that than to just go buy another plot of land and build a tornado-resistant home. And this is the same thing here. If you keep just trying to fix the little things and upgrade, it costs more to upgrade afterwards than to build it into the system. This is a smart, efficient way to do it. I always tell people I'm an engineer. Engineers, two things. We want to be on time and we want to be under cost. Or better yet, we're cheap, and lazy. I want to get done early, and I don't want to spend a lot of money. I'm cheap and lazy as an engineer, and that's what severe. And I say it jokingly. I mean, they're not being cheap. They're not sticking junk in here. So that's let me cut to another thing though. You talked about EMP, and we have the other piece about EMP is we understand EMP so much better today because of this high computational capability, because it is a very, very complex. Electromagnetics is very hard to replicate. We're not doing testing in space. We're not doing testing in upper atmosphere. So everything has to be simulated in some fashion. I worked with some of those rudimentary codes, and they were good codes. They gave you an answer, but they didn't give you the answer. And as all computational codes, they're all wrong, but some are useful. And the more we understand, the more useful they become in these very complex systems, like an airplane. It's not just a Tylenol flying around in the sky. There's all this stuff happening, and it's got to be thought through. So that's the other piece that really helps out. Now, the second piece of this is from a nuclear survivability standpoint, before I even get to the communications, is they're also building into it radiation survivability, because our adversaries, and this is something I want our audience to understand. I really key in on this when I talk about this in teaching. Our adversaries are getting better at putting their munitions closer and closer to the target. And when you move closer to the target, you have other effects that are become challenging. Aside from an EMP for a high altitude burst, the radiation from a nuclear weapon, the shock and blast, and they are building that into the system. Yay, that should happen. And that is, because you don't want to be in that aircraft when suddenly one of the wings falls off. Okay, it's probably not a good day. It's probably your worst day.
Well, there are not 65 shoots.
And the radiation, if they're close enough where radiation or thermal shielding is a problem, so they're building that into the system, highly survivable. So the S on this is really, really important. It's not just EMP, it's survivable in many ways. Did you have something to say before I ran off the computer? I'm just
So I want to you are. Let me just add to this in that. So even though, to your point, sometimes it's cheaper to start new. Sierra Nevada is actually using these refurbished aircraft, right? They're buying these sort of used aircraft. We don't know what the flying hours are on the airframes or these sorts of things. Let's make an assumption that they're low. But my presumption is that they are stripping these things down to the bare minimum, to the bare metal, and then sort of rebuilding from that perspective. That's my guess of what's going on. And I think it's interesting here just to note that the reports are that they bought 5 of these 747s for a mere $674 million total. Now, my guess is we wouldn't have been able to buy a new one for that price.
Yep.
So to get 5, what I'm going to presume to be, low mileage airframes, that's probably a pretty good bargain. And then the bulk of the remaining $12 billion plus is all of this work and modernization and new components that are going in. So I think the plan is, of course, that they've got 4. The plan is to get to 5, which is a good thing because there are only 4 E-4Bs now, and it always have been only 4. And that's always been a challenge. There have been years where they're only running, a 55% readiness rate. And I think last year they achieved a whopping 61% availability rate, which seems pretty good, but that's I think if I do the public math, that's only 2.5 jets available at any one time. And if you've got one jet on alert waiting to do its mission at a moment's notice, and another one either flying for training missions or supporting the Secretary of War or the President, then you're kind of out of opportunity there. And so getting to 5 should really help increase that readiness rate so that when the jets are in maintenance and undergoing upgrades and things, you still have more to play with. I mentioned that I flew these airplanes on 9/11. This was a rare occasion, national dumb luck. But on that day, we had all 4 E4s operating.
Oh, wow.
And it was a rare time, and we had all been generated for an exercise that day for that evening. So all the crews were ready to go. It's just dumb luck. So, but that we can't count on. So you want to make sure that your aircraft are ready to rock and roll. And the new E4C, Survivable Airborne Operations Center, is expected to come online to be fully operational, and I would assume with all 5 jets by the mid-2030s. So it's about 10 years from now. But that tells me, though, Jim, they're going to trickle in, right? And so for a few years, they're going to have a mixed fleet. And that's going to be a little bit of a challenge in training and certification and these sorts of things, spare parts, maintenance work, and so forth. But I'll tell you, when I was there, we had a mixed fleet as well. We were digitizing. The fleet was beginning to get digitized in some aspects, while the remaining fleet was still what we refer to as analog steam jets. Yep. And so you had to get qualified on both types of aircraft because of the kinds of systems that were engaged, at least in the front end perspective. So this is not new to that community in sort of working with a mixed fleet. So I have a lot of confidence in their abilities to work through that. One last thing to kind of go through here, and then I want to hand it back over to you for your closing thoughts, is to make mention this 747-8 is a much bigger jet than the 747-200. It is reported to have Oh, it's supposed to have it's about 19 feet longer, which is a lot of room to work with considering the components are smaller in what they need. And, of course, the wingspan is about 28 feet wider, which has some impact on infrastructure, hangar space and these sorts of things, parking. The jet is heavier, which was going to impact ramp availability and runway availability, so they'll have to consider that. However, the jet engines and so forth are much more efficient. They expect about 1,000 miles more range.
Wow. And heavier
more efficiency.
aircraft.
Yeah, and the engines are so much better that the jets can reach a 0.85 Mach, which is reportedly making it the fastest commercial jet in the world, which is very interesting. And of course, the efficiencies mean less carbon emissions, which will keep all the green brains happy in that regard. And so, I think there's a lot to love about this as we go through this. Still, the requirement for a 4-engine airframe, and Jim, that was part of the long pole in the tent here, because there aren't that many 4-engine airplanes being built in the world, right? The 747-8, I think, is the last American version. Everything's gone to these 2-engine systems, and so our listeners might be wondering, well, then why do we have a 4-engine? Well, the 4-engine requirement is because you need to be able to operate if you lose an engine. And there's a lot more confidence doing it on 3 than on 2. And then the other requirement is generation. You got to have a lot of power generation, and sometimes you can't do it just on 2 engines. So you got to have 3 or more in order to generate the kind of power you need to do the communications work that you were describing and that I was describing in these austere environments. And so all of those things matter. Of course, these airplanes are air refuelable, which means they can fly for a long time. I think they're limited by the oil life. And when all the bathroom facilities begin to overflow. That's sort of the limitations on the airplane.
Well, I was going to ask, with that extra space, you got all those people on board. Do you think maybe they might install a snack bar or something in there?
Oh, they do.
Yeah.
They have flight stews, and they serve great food. I tell you what, as an old war story, if you're flying, if the flight stew was getting a check ride, you wanted to be on that jet because they were going to cook a great meal. They go through the Air Force Culinary School, the same ones that deal with Air Force One and all of that. It's a profession that is one unto its own. Our enlisted force that does that work are stupendous, and they do fantastic work taking care of the passengers and crew on the airplane and offering the food service that goes with it. It's fantastic. Never miss a meal on the NAOC or the SAOC, I presume.
It's incredible what our airmen do, and the kind of things that people don't realize are opportunities within the Air Force that would be great. Although I'd say I'd like to know when they do the first steak and lobster night on the SAOC, just to see how that happens.
I tell you what, that would be awesome at 35,000 feet. Expensive, terribly expensive, but nonetheless.
Yeah,
go ahead. You close us out.
Well, there might be a little bit of time, but I'll come back to you. But I did want to talk a little bit about the communications, because that's the other part of the mission. And again, looking at how this was, and you sort of alluded to that a little bit earlier, in that they went from analog to digital. That was all a change out in electronics, everything else. The original systems that came out of this was, HF, VLF, UHF, sort of line of sight communications. But one of the things I think that was most interesting, and what comes in now, is almost all of that was analog, and analog communications, are good. There's value in analog. One of the things that happens with digital is you can do digital correction. So if an event occurs, a nuclear weapon, or someone dazzles you electronically,
scintillation,
all kinds of things can happen in a nuclear environment, or even in any kind of contested environment, or even a storm environment with lightning, etc. You can, if you've ever listened to an analog radio and you listen to people talking and you hear that crackle, 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 if that's information you need to have, you'll miss that. But digital communication can one send out a blip, and if it's been interfered with, and automatically correct for it, or recast for the signal because it can come quickly. And then the other piece is the cybersecurity that's on there, because we are looking right now. I mean, today's digital. First of all, the Air Force does a great job of this, and the Navy and the Army. I'll give the whole Department of War and the subsequent elements of it. All of them great credit in the way that they do. The communications and technology enhancements. But we have all of those same systems, enhanced digital modulation, which wasn't in place. There was no digital modulation when the system came out. SATCOM wasn't existing when that first aircraft came out. Okay, they had to add that in. It was an add-on. Now correct. It's built in. It's jam resistant. It's secure. The satellite links are there, but if the satellites go down, they have dynamic radios. We never had dynamic radios back then, where a radio is software controlled, so you can change the frequency set, change the frequency matching and controls on that. All of that, switching is there to make it more secure. You have, I imagine they're, think about modular. We ever come out with this idea of, quantum communications or quantum secure
laser
protocols?
Communication.
Yeah, they can just pop those in. So this is why we need to modernize, so we can stay ahead of our adversaries who are already looking into this stuff. And now we can do that too. And so I wanted to point that out, that it's really, really important that we understand that it's not just about a new pretty airplane flying around. Oh, and while I'm talking about the pretty airplane, you mentioned hangar space. Dayton built, Sierra Nevada, sorry folks, Sierra Nevada built 2 new hangars at Dayton. I saw them when I landed last time I was traveling. They're building 2 new hangars just to be able to, do all the outfitting and everything here. That says a lot about the Dayton region, the garden spot of the United States of America, how quickly they respond to the needs of the country. And that's good for our region. So I wanted to point that out to everyone. And that's sort of where I live.
Right.
And if they can pay more of my taxes and I can pay less, I'm happier for that. That's a different issue. Yeah. But so as we close out though, Curtis, I do want to hear from you. Just one last thing. If you were in uniform today, what would you be doing now? I mean, talk about the preparation probably be going on, or maybe 5 years from now when they begin to look at getting onto a new system. What kind of setup, what kind of things would you have to be doing to walk into a new system and make sure it was functional? Because a lot of that training has to start happening soon. So new members are, understanding how the equipment works, et cetera. How does that go along? Because there's got to be some training involved in this. You just climb on an airplane and voila, you're a SAOC navigator.
Well, I mean, it's a great question, and I'll say it this way: probably a year out from receiving the first jet, they'll start selecting and sending pilots to some airline to go and get their Dash 8 qualifications. Because learning how to fly the airplane, they'll have to contract out some simulator time and actual jet time, because it's a different jet. It's, as I mentioned, how much bigger it is, and so that's going to matter as they get ready for the first jet. My guess is that whatever navigation work is there, it's going to be highly digitized, and it'll just be learning how to use the boxes. And so I don't expect that to be a whole lot different. And the flight stews and them, they'll learn how the safety features work of the airplane and the egress and these sorts of things. That will be fairly easy. That can be done on the ramp and sort of local training. Now the comm operators, they'll have to learn the new radio systems. My guess is that they have some school they'll go to that they'll have to upgrade and sort of learn how to use all of these new systems. At least an initial cadre will do it, and then it'll be a train the trainer system, and then they'll come back to the unit. Everything's done in-house in the first acts at Offutt Air Force Base, and so they'll learn how to sort of train each other in that regard. The battle staff, it's fairly, they rotate through all the time. They have a training program. They'll just learn on the new systems. I think it'll be fairly simple. I think the maintenance will go through a lot of training as well. One of the unique things about NAOC that I think will still occur on SAOC is that, of course, the crews sit on alert 24/7, 365, and generally you're on alert for 7 days as a specific person in whatever position you're in. And one of the things that our maintenance folks are qualified to do is to start the engines. And so they'll have to learn and all of that sort of thing, how to start all the engines. And they won't move the jet per se, but they can start all the engines. So everything is up and running by the time the front end crew, the pilots, get into the cockpit and actually sit down. Because when the jet's on alert, there are certain crew members that are actually on the jet.
Wow.
All the time. So it makes the response time much faster and that sort of thing. Unless for some reason they have to be on the front end has to be on the jet for heightened conditions or training or whatever the case may be. But in any case, these can matter. So there's that kind of training that will have to go on, and I expect. I mean, who knows if Sierra Nevada will be part of that training initially or not, I don't know. But let me add to this here as we're closing out and congratulate the Sierra Nevada Corporation. It's a small, I think, a family-owned company. It's I was reading that this contract that they have is the largest in their 60-year history. At least it said that's what the article said, 6-decade history. So it might not be totally 60 years, but in any case, in how they are accounting. And so I think that's a tremendous feat that we as a nation have entrusted an innovative company that is not one of the biggies, the Boeings of the world, so to speak, to actually do this work. And it might be one of the reasons why they're able to, I think, going to be able to do this so quickly and innovatively and get out and utilize these refurbished aircraft and push with subcontractors to get the equipment done. And so I'm hopeful that they might actually be able to be ahead of schedule. That would be a very nice surprise, I think, because these airplanes are needed. The 747, even in 2000 when I was flying them, were still sort of the Cadillacs of the Air Force. Well, it's 25 years later.
Yeah.
And so they're starting to get a little long in the tooth as well. As I mentioned, it's hard to get parts for them anymore. And so the problem set for them today, much worse than it was when I was flying, like I said, some 22 years ago. I can't believe it's been that long. And so it is something that is of concern. And one thing about our great Air Force is that we ought not to be constrained by the limitations of our of time and parts and acquisition bureaucracy. It really does hold things back and affect our ability as a nation to posture forces in order to deter successfully. I think it matters, and by great work of people, we've managed to be as successful as we are today. But it is not without great effort, and so I really welcome this upgrade, this update, this modularization, and the great capability that will come of the modernization in making this mission even more efficient going into the future.
Well, good. I appreciate that, Curtis. And I don't know if it was you, Curtis, or we were teaching in a class somewhere, but I recall that someone said that during the Cold War, when we did bring the Russians, I guess the Soviets back then, over to the United States, and they talked about or looked into our NC-3 system, someone said that one of the Russian generals said, or Soviet general said, the biggest thing that scared them about our nuclear capability was our NC-3 system and our ability to command and control our nuclear forces. And this aircraft is a key component to that ability. So I don't know if you said it, but you might remember that comment made by one of the instructors.
Oh yeah,
But,
I sure do remember it. Yeah, and there's no doubt about it that it was influential between the NAOC and the Looking Glass. It was influential in the decision making for Russians to wake up every morning and say "Niet, not today."
That's
And
the way we
so,
want it.
and that's what you want. That's a successful deterrence. A deterrence is binary. You're either in war or you're in peace. And so my guess here is that we've had a lot of successful wins with regard to nuclear deterrence, and this has been a key component of that and will continue to be, thankfully, to the efforts to do this modernization.
Well, great. Yeah, and unfortunately, we have to close our time here. I want to make a quick correction. I opened this by saying in air warfare, this article is out. It's actually in Defense News. You can find
Defense
it
News,
online.
yes.
Yeah, it's called Flight Tests Begin on U.S. Air Force's newest doomsday plane. I also, we've talked about Sierra Nevada quite a bit here, but I will say, at least according to the aviationists, there are other key partners: Collins Aerospace, GE Aerospace, Lockheed Martin Skunk Works, Rolls-Royce, and Wichita State University's NAIR program. I don't know what that stands for. I'll look it up later on. But I went ahead and looked that up because I didn't want to skip out organizations. But I would invite any of them to come onto this podcast and talk to us about how this is going, how we can let the country know how important this work is as part of our deterrence. And with that, I'm going to close this out by saying thank you, Curtis, for your service to our country at the NAOC. Thank you to all those people that may be listening to us that serve in that mission right now, and of course to our great Americans that are serving our country and keeping peace throughout this globe. Once again, we are open to finding more guests. If you're interested in knowing more about us, go to our public site at thinkdeterrence.com. Read our articles on the GSR, the Global Security Review. Listen to our podcast. Sign up for our HUSI events. Become a part of what we are and help us to get the word out to your friends and family so that they understand the value and the importance of doing what we always ask you to do, which is think deterrence.
Thank you for listening to the NIDS View. This show is produced under the NIDS Podcasting Network, a division of the National Institute for Deterrence Studies. NIDS is a 501c3 organization dependent upon donations to provide this podcast and bring about awareness of the peacekeeping value of U.S. strength and our national deterrence. You can catch all of our podcasts or provide feedback at thinkdeterrence.com. I would like to thank our producer, Kimberly Charrington, our sponsors, and all the fantastic members of the National Institute for Deterrence Studies for making this podcast possible. Stay tuned next week for another exciting and informative The NIDS View.
The NIDS Podcasting Network.